All right, in this lesson, we're going to look at applications of polynomial equations. So really the key thing that we're going to be doing is we're going to try to set up some sort of polynomial function to represent a situation. Once we can do that, and usually we'll want to try to set up some sort of equation specifically so that it's equal to a particular number. And then we just need to apply what we've done in the previous lesson. So to solve that equation, we can factor once we get everything to one side. So really that's the key, is get that polynomial function, that equation set up. Then it's just a matter of factoring, which hopefully by now you've had some good practice doing. Okay, so the tough part then is how do we create these equations? So let's take a look at a box example here. This is a pretty common situation for these kind of polynomial function type questions. So we have an open top box, so it means it's a box. You've got a box here, but it's got no top. So the bottoms are all filled in, but the top is empty. And we're going to do this by making it from a sheet of aluminum, 50 by 30 centimeters, cutting out the 4 squares from each corner and folding up the sides. So basically we're creating a net, and that net will then fold into kind of a box with its top. So let's see what I mean by that. So let's draw that rectangle first of all. So that rectangle, that's our 50 by 30 centimeter sheet of aluminum. So what we're going to do is we're going to cut some squares out. So a square from there, exact same square from there, a square from there, and a square from there. And then what ends up happening is you can fold this along these dashed lines. So fold that part up, fold that part up, fold this part up, fold this part up, and that will create, they'll join together to make the walls of a box. And then the orange rectangle is the bottom, and there is no top. So that's how we're creating this box, and we know that the volume of this box is going to be through 4,000 centimeters cubed. So what we need to do is we just need to figure out, well, what is the polynomial function that represents this volume, and then how do I create this box? What are the side lengths that I need to cut out? So let's start with, well, the missing piece of information is the side length that I'm cutting out. And since these are squares, all these side lengths are the same, so I'm just going to label an X basically everywhere. It's representing the side of a square, so let X represent the length cut out. Okay. And now how do we get this function made based off this situation? So what we're going to have is, well, just in general, the volume is just length times width times height. So we just need to figure out, well, what is the length times the width times height? What are those 3 separate measurements? So we're just going to do that. And then we'll put it all together to get our volume. And then hopefully with that, we can solve this problem. Okay, so we need to keep in mind that we're cutting out these parts. So we're cutting out I'll do it in cutting out this, 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 and this. Okay, since those are being cut out, and we have this orange rectangle now, what is the new measurements of that orange rectangle? That orange rectangle at the bottom, that's basically our new length and our new width. And then, well, what's the height? Well, actually the height, because we're folding these outer parts over, the part that we're cutting out, the X length, that length becomes our height. So right away we can actually just put the height, that's just x. Okay, but the length and the width. So the length is just the orange length. But what we can see is that we have an x to the left of the length and x to the right of the length. But what do we know? All the way across is 50, but we're now missing 2 of those x's. So the length is actually just 50 minus 2x. And let's look vertically. We know that the entire vertical width, I'm calling it, is 30 centimeters, but I'm missing an x and another x at the bottom, so that's going to be actually 30 minus 2x. So putting this all together, I can say I'm going to call it v of x, because it's all in terms of, well, the part that we're cutting out, the x variable, is just going to be the height, length, and width, all multiplied together. I just put the height first because it's just nice to have the x at the front there like that. And well, what else do we know? We also know that the volume, well, it's got to be 4,000 centimeters cubed. So what can I do? Well, I just need to set the 4,000 equal to this particular polynomial function. Okay, so there it looks like we've got a nice polynomial function. We can solve this. It almost looks like we're already close to solving it because it looks factored, but we're not quite factored. Because even though on the right-hand side we do have those 3 things multiply, to solve the equation, we need to have everything, including that 4,000, on the one side of the equation. So I'm going to set it as 0 equal to x times this times 30 minus 2x minus the 4,000. And since we have this minus 4,000 there, that means that's no longer in factored form there on the right, because everything needs to be multiplied. You can't have just one part like the 4,000 outside of it. So how do we get that back into a factored form? Well, what we need to do is we need to get it into standard form. And then factor. So to get it into standard form, yeah, we need to expand it out. So I'm going to leave the x on the outside for now. And then expanding it out, what you'll get is 1,500 from the 50 times 30. We're multiplying both 50 and 30 by negative 2x, which will lead to negative 160x. And then 2x and 2x give you 4x squared minus 4,000. Okay, and then multiply the x in, so you will get, and I'll reorder things so it's in terms of powers of x, so 4x cubed minus 160x squared plus 1,500x minus 4,000. There we have it. We have something in standard form. So now we want to leave the 0 there on the left. Now we want to get this just regularly factored. So we can start with common factoring. Is there anything that multiplies into all 4, 160, 1,500, and 4,000? Well, in fact, the number 4 does. So factor that out, and you are left with 40x squared. 1,500 is actually 375 then, after you divide by 4. And then minus 1,000. Okay, so now what are we going to do? We're going to factor this, which again means use factor theorem. The last number, the constant, is 1,000, so check factors plus or minus 1, 2, 5, 10, so on and so forth. Yes, there's a lot of factors for 1,000. Since we're looking at like a length that we're going to cut out, it may be reasonable that this thing shouldn't be too big because our whole aluminum sheet is just 30 by 50 centimeters. So we can't cut out something too big, so we should be able to find something smaller. All right, so let's, I guess, go ahead and use factor theorem. So start testing numbers. If you test out 1, well, look at those numbers, 40, 375. Things aren't going to cancel out when you check out 1. So you can kind of skip past that, just visual inspection. If you try out 2, that's not going to work. 3, 4 are not factors of 1,000, so you can skip those. Plug in 5, and well, what do you know? 5 cubed minus 40 times 5 squared plus 375 times 5 minus 1,000 does actually end up giving you 0. And also, since we're looking at lengths to cut out, if you were to check out negative values, sure, you could get a negative factor, but it wouldn't be reasonable as an answer because you can't cut out a negative length from your aluminum sheet. Okay, so we have x minus 5 is a factor. We still want to check if this whole thing factors. So we do need to fully factor it because maybe there's multiple answers here. So we do need to be careful of that. So I'm going to use synthetic division. We have 1, negative 40, 375, negative 1,000. And we've got the 5 on the outside. So drop the 1, multiply by 5, combine those two, and that gives you 35. Multiply by 5. This is where you need to pull out your calculator. That's going to be, negative 35. And then multiply that by 5. Okay, that's going to be negative 175 plus 375. That nicely gives us 200. With 5 gives you 1,000, which cancels out with the negative 1,000, leaving your remainder 0, which is what we want. Okay, so then we know that our polynomial 0 is equal to 4 times x minus 5 times x squared minus 35x plus 200. Okay, so x squared minus 35x plus 200, you could try seeing what multiplies to 200 and adds to negative 35. That seems a little bit tricky. So I'm just going to opt to use the quadratic formula. So let's do that. Quadratic formula. So make sure you know your quadratic formula. There are times where you may need to make use of it. So we will have 35 plus or minus the square root. It's going to get a little bit messy, so we'll just round off the answer. That's fine. 4 times 4ac is 1 times 200 in this case. And this will work out. It's not going to end up with a negative square root. You will get an actual thing that's square rootable with actual numbers. And those actual numbers, once you plug that in, so go ahead, type that in. You should get 2 answers, 27.8 or 7.19. So yeah, we're just rounding things off. That's fine in this particular case. And then, of course, we also have the answer 5. Okay, so we have 3 different answers. We just need to actually be careful about these answers. Do they all make sense? So 5, you could cut out 5 centimeters. That works. I'm just adding the units to these answers. 7 centimeters, you could cut that out. Let's be careful about the 27.8. You actually can't use that answer. Because if we go back to the original situation, we have this rectangle. If we're looking at, let's say, the width itself is 30 centimeters. You can't cut out 27 centimeters from the top and the bottom. Otherwise, that's going to overlap. So that's not going to work. So we can't cut that from both sides. So therefore, we can cut 5 centimeters or 7.19 centimeters. Make sure to include units, length, squares. Yeah, there's 2 answers. Basically, the one answer is let's say a flatter box, whereas the second answer is a more taller box, but both of them could still have a volume of 4,000. Okay, and that's a look at that word problem. So in general, the key to word problems is get that polynomial set up. Once you get it set up, it all comes down to factoring. That is the important skill that you're making use of, is the factoring. But to be able to get to that factoring, you need to be able to set up your polynomial. So read through the questions carefully. If you need a diagram, definitely draw a diagram, and definitely try some practice these kinds of questions yourself to get used to them.